Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 3 to the power of x plus 3 to the power of x plus 2 to the power of x is equal to 5. Now what I'm first going to do is I'm going to factor out 3 to the power of x from our left-hand side. So now we have 3 to the power of x times 1 plus 1 plus 1. Now this is equal to 5. Now 1 plus 1 plus 1 is 3. So now we have 3 times 3 to the power of x is equal to 5. Now I'm going to divide both sides by 3. So now we have 3 to the power of x is equal to 5 over 3. Now I'm going to take the log of both sides. And whenever I have a logarithm in the form log a to the power of b, I can actually move our exponent here, b, to the front of the logarithm. And this is known as the power property of logarithms. So this would be equal to b times log a. So now we have, I'm actually going to move this x to the front. So now we have x times log 3 is equal to, now log of 5 over 3 is the same thing as log 5 minus log 3. So now I'm going to divide both sides by log 3. So then these two cancel out, these two cancel out, and I'm left with x is equal to log 5 minus 1. And log 5, sorry, is for log 3. So now the value of log 5 is equal to approximately 0.6990, and the value of log 3 is equal to 0.4771. So now if I plug these in, I get 0.6990 over 0.4771 minus 1. And this means that x is equal to, if we simplify this, this would be equal to 0.4651. So this is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 2 to the power of 1000 minus 2 to the power of 999. So now to solve this problem, I'm going to first rewrite this as 2 to the power of 999 plus 1 minus 2 to the power of 999. So 1000 I just rewrote as 999 plus 1. Now, if I have something in the form a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So now 2 to the power of 999 plus 1, we can think of a as 2 in this case, m as 999, and n as 1. So now this is going to equal a to the power of m, so 2 to the power of 999 times a to the power of n, so 2 to the power of 1. And now I have this minus 2 to the power of 999. Now, to simplify this, I'm going to factor out 2 to the power of 999 because both of the terms have 2 to the power of 999 in them. So now I have 2 to the power of 999 times, well, 2 to the power of 999 times 2 to the power of 1 divided by 2 to the power of 999 is simply going to be 2 to the power of 1. Now I have this minus 2 to the power of 999 divided by 2 to the power of 999 is simply 1. So now, 2 to the power of 1, well, this is the same thing as 2. So now I have 2 to the power of 999 times 2 minus 1. Now 2 minus 1, this is simply going to equal 1. So I have 2 to the power of 999 times 1. And this is equal to simply 2 to the power of 999 because anything times 1 is itself. So 2 to the power of 999 is our answer. Alright, so I have 3 to the power of 20 plus 3 to the power of 20 plus 3 to the power of 20. Now for this problem, I actually have 4 answer choices. So for answer choice A, I have 3 to the power of 60. For answer choice B, I have 60 to the power of 20. For answer choice C, for answer choice B, I have 9 to the power of 20. For answer choice C, I have 9 to the power of 60. And for answer choice D, I have 3 to the power of 21. Alright, so let's first go over all of these answer choices. So for answer choice A, 3 to the power of 60, how you get this is you simply keep the base the same and you add the exponents. So you have 3 to the power of 20 plus 20 plus 20. And 20 plus 20 plus 20 is 60, so this results in 3 to the power of 60. And this method is actually wrong because that's not the way to add exponents. So now for answer choice B, what you do is you keep the exponent the same and you simply add the bases. So you have 3 plus 3 plus 3 to the power of 20. And 3 plus 3 is 6, 6 plus 3 is 9, so I get 9 to the power of 20. And this method is actually wrong as well, because that's not the right way to add exponents. Now for 9 to the power of 60, you do both of them. You add all the bases and you add all the exponents. So then this results in 9 to the power of 60, and this method is also wrong as well. So now for our final answer, which is the right answer, how you get this is, well, first start with 3 to the power of 20 plus 3 to the power of 20 plus 3 to the power of 20. And now from here, I'm going to factor out 3 to the power of 20. So now I have 3 to the power of 20 times 1 plus 1 plus 1. Now, if I simplify this in the parentheses, I get 3 to the power of 20 times 3. And write this as 3 to the power of 20 times 3. And now 3 here, this is the same thing as 3 to the power of 1. Now, if I have something in the form a to the power of m times a to the power of n, this is the same thing as a to the power of m plus n. So in this case, this is going to equal 3 to the power of 20 plus 1. and now this is equal to 3 to the power of 21. So this is my answer. Alright, so I have 5 to the power of x plus 2 is equal to 4 to the power of x. Now, I obviously want to find the value of x for this. So for my solution, first start with 5 to the power of x plus 2 is equal to 4 to the power of x. Now, I'm going to take the natural log, or also ln, on both sides. So now I have ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now, an important property of logarithms is that if I have something in the form ln a to the power of b, I can actually move this exponent b to the front of the logarithm. So this is going to equal b times ln a. And what makes this property so important is that, let's say we had 7 to the power of x is equal to 9. Let's say we had this problem. So now, as you can see, x, this is an exponent. And it's going to be really hard to solve for x because we know it's going to be a decimal. Because if you notice, 7 to the power of 1, this is 7, and 7 to the power of 2, this is 49. So the value of x is going to be somewhere in between 1 and 2. So now to find the value of x, at its current state, it is really difficult. However, by using this property, if I take the ln on both sides, I can now move this to the front, so now I have x times ln 7 is equal to ln 9. And now, as you see, x is a normal term, and it is much simpler to solve for x. Now all I have to do is divide both sides by ln 7. These two cancel out, and I'm left with x is equal to ln 9 over ln 7. So that's why this property is so useful. So now for our original problem, I had ln 5 to the power of x plus 2 is equal to ln 4 to the power of x. Now I can move both these exponents to the front. So now I have x plus 2 times ln 5 is equal to x times ln 4. Now I'm going to go ahead and distribute ln 5 to both these terms. So now I have x times ln 5 plus 2 times ln 5 is equal to x times ln 4. Now I'm going to subtract both sides by x times ln 4, and I'm also going to subtract both sides by 2 times ln 5. I have x times ln 5 minus x times ln 4 is equal to negative 2 times ln 5. Now from here I can factor out x, so now I have x times ln 5 minus ln 4 is equal to negative 2 times ln 5. Now if I divide both sides by ln 5 minus ln 4, these two cancel out, and I'm left with x is equal to negative 2 ln 5 over ln 5 over 4. So this is my answer.